Okay, so let me, first of all, I have to remember how to use an index buffer. So like this, the order of the drawing, and I'll just pass it in like this. Great. So just to make sure I'm doing this right, I'll just put in 1 to 20 or 0 to 23. I guess I could just literally put in list of range 23. But since I want to edit this, I'll just do it this way. Alright, this should render the same square. Man, I hate image magic. Such an annoying program. And that is the wrong thing. Okay, so that worked. Now I'm doing it with an index buffer. And now what I want to do is like for each curve, I want to do like 0, curve point 1, curve point 2, then 0, point 2, point 3, then 0, point 3, point 4. I think I'll actually have to draw this out or something. I'll be given like T0. Oh, hey, what's going on? I'm given something like this. 0, 0, 1, 0, 2, 0. And this will go to 1, 2, 3, 4. And same with this. So given these points, and I want to convert it into, and I'll just have one called origin or something like that. And I want to do origin that point. Actually, this isn't even totally right. This is assuming that each one is a 3D point instead of a point that's part of a Bezier curve. So what I should be doing should be like P0, control 0, then like P, I'll call it B. Just trying to do that. P A0. No, I just have to do it like this. PB0. PC0. I wanted to use C for control, but I guess that's not gonna happen. Anyway. This, I want to take to origin, this, origin again, this, origin again, this, and how would I find the indices for this? And even this, I'll have to split it up for each origin again, this, and how would I find the indices for this? And even this, I'll have to split it up for each curve. Won't I? Actually, I don't think I will. Assuming those points will be closed on their own. Which honestly, I don't know if they are. Okay, here's what I have to do. I'm gonna put a breakpoint here. Then run this. Okay. Here's the points in that E. Now, there's gonna be some place in this outline of an E where the end point of one curve and the start point of the next curve is very far from each other. So I think I could do Avon import numpy as np. I can say r 1, 2, 3, 4, 5. Then r from 1 on is this. Or r from 1 to, is this len r? R.size or whatever? I think it r from 0 to r.size minus 1. And these are the ones I want to compare. I think in the other order, so I want this, and then this. And I'll have to see what's the difference between this and this, this and this, this and this, this and this. So if I take... No, it was the other way around. This, and then this. And if I subtract these, I can get P2 minus P1, P3 minus P2, etc. So if I did this minus R0, this will give me the differences. And is that what I want? I think it is. This ended up being some complicated math. So I'm just gonna try doing that here. Can you do E points? From 1... First, let me see the shape. Like this. Oh, it's not an NP array. Okay, so it's 144 points. They're three-dimensional. And I'm basically going to copy this. 1, going to er.shape 0. Okay. Minus from 0 up to, and then not including that shape 0 minus 1. Okay, these are the differences between the points. Makes sense that a lot of these are zeros. Let me call this diff or something. Let me call this diff or something. Look at the shape of this. 143 that are three-dimensional, that makes sense. Now, there should be a few points. There should be, I think, 1 point that's very far away. Because it's going to do the jump from basically the end of one curve to the start of another. And there actually has to be a place where Manim does this. Okay, so I'm going to take the norm of all of these. And I don't know if that'll go row-wise. It didn't. X equals 1. I don't get it. Out of bounds for array of dimension 1. Oh, it should be diff.shape. So will this do what I expect? Nope. Okay, so this is the norms of those differences. And is any of these unusually large? Honestly, it doesn't really look like it. There are quite a few zeros, though. I guess this 0.5 is fairly large. But then there are 2 of them. I guess I have to see how Manim makes this difference. If Manim even makes the difference, though. It might not. But then again, I don't even think it matters for this triangulation. Does it? No, it does, because I need the edges. Or does that even matter? I think it doesn't. I think this was a red herring. And the reason for that is that if I have some points, say I have some like this, and then there's a disconnect, then I have it from here, it goes onto this curve, then I can take like P0, here P0, then P1, and that's an edge. And then P1 will be repeated. So then I'll have P2, and then ending with P3. Then P3 won't be repeated. I have P4, and start there. At least I can do that as long as this is actually repeating each endpoint. And it is. Here, this is being repeated. Didn't want that to jump down there. Wait, can I do this without it? That's annoying. Here, this is being repeated. And there's a control point. This is being repeated. This is actually kind of bad. This is a lot of repetition. But it's working out really well for my life right now. So I guess that makes this easier. a little easier. How is this better than the current text rendering? I actually don't know how long ago you asked that. So sorry. But the reason it'd be better is rendering. I actually don't know how long ago you asked that. So sorry. But the reason it'd be better is for a few reasons. The first one is the current algorithm that's used for text rendering. It's also used for rendering quadratic Bezier vectorized objects, those. And it's sometimes wrong. Sometimes it just renders the wrong thing. So that's one problem. The other problem is that all of the shaders Grant wrote don't work with model view and projection matrices, which means zooming and panning with them behaves weirdly. So it'll fix both of those problems. Okay, so there's a good old E array. And now what I want to do is take out all of the midpoints, which I have no idea how to do that. Is it faster? I think it should be the same speed, actually. This is going to be a weird way of indexing. Basically, I'll have an array like this. 0, 1, 2, 3, 4, 5, 6, 7. And I want a way to index this one, and 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 so on. Wait. This one. And so on, like this. NumPy.where to delete a specified element from an array. Where condition. Okay, this is doing a condition on the element itself, which isn't that helpful. Maybe I need to do numpy.indices, where the subarrays contain index values 0 to 1. Right at 0. Don't think that's what I want. Do I want choose? From an array, from an index array and a set of arrays to choose from. Man, NumPy is hard. 2, 3, 1, 0. And it picks from this array, then this array, then this array, then this array. Interesting, but that's not what I want. Dang, I feel like I'm at a loss on how to index this. Take values from the input array, matching 1D index and data slices. Well, I guess finding the indices for this wouldn't be so hard. If this was the array, then the index array would be 0, 2, 3. And the index array would be 0, 2, 3, 5, 6, 8, etc. Zero, 2, 3, 5, 6. I should be able to construct this array. I think. Return elements, just X, Y, depending on condition. I wonder how to use logical indices. Well, I think a logical index won't help. I want like... I want to do like array indexed at... I wonder if that would work. Like index an array with another array. I can do a at 0, of course, a at 2. We did a at np.array. Oh, I did that wrong. And it does work. Then I can do like, for instance, 2. Then, I don't know, 6. Okay, I think that helps. Because now, all I need to do is construct this array, which is much more nicely structured, I think. So next question is, how can I construct this? It's going to be 8, 9... Just gonna skip one, it'll be 10, 11, etc. Would this be like, I think there's a tile function that does something like this. Construct an array by repeating a the number of times given by reps. Not quite. Actually, what are these indices? The negative indices are 1, 4, 7. That's just starting from 1 and adding 3. So if I could just take this array, this range or something, this is like the negative indices. So I'll call NBX. So on 8, 9, skip that. I'll do 11. The negative indices are just 1, 4, 7, 10. So these are really easily structured. So if I could delete the array at certain indices, that would be even easier. Is it numpy.delete? Indicate indices of subarrays to remove along the specified axis. Okay, I think that's perfect actually. Indices of subarrays to remove along the specified axis. Okay, I think that's perfect actually. Is it? It's either linspace or something else to get the numpy equivalent of range. I think there's a better one. A range, I think. Don't know what the A stands for. Now I could do mb.a range. And for example, then I can do numpy.delete. I wonder if dot delete is a thing on the array. Nope. Okay. Numpy.delete this. Then I could do 1, 4, 7. I don't know if it has an index 10. Okay. But that's giving me the array that I want. So now the question is, how do I get this array? Am I thinking about this too hard? I want to be able to parallelize it. So I had 1, 2, 3. Can I just take each index? I can just take 1. Maybe about ones. Like 10? Then to each one I'm going to add like 3 times the index. A range 10. I'm gonna range it 10 times 3. So I can do numpy.ones 10 plus np.a range. Oh, dot a range 10 times 3. Okay, that gives me the index array. Great. The negative index array. Okay, so I found an expression for this. One, 4, 7, 10, 13. Okay, great. So then what's this? np.a range len. Then I'll delete. Or was there a way to get something just from this, I wonder? Probably not. np.delete. Oh, np.a range len. .delete. ndx. Oh, not delete, but like this. Can I do this? Arrays used as indices must be of integer or Boolean type. Can I just convert this to integer? Yeah, can I just make this an int32 somehow?